In 1997, world chess champion Garry Kasparov sat down across from a machine called Deep Blue and lost. The world kind of panicked a little. Fast forward to today, an AI doesn't just play chess. It plays Go, Starcraft, Dota, poker, and it's often unbeatable. So how does a computer actually figure out the best move in a game? Sometimes a game it's never even seen before. Let's open the hood. Here's the part that trips people up. Chess has more possible games than there are atoms in the observable universe. Seriously, more than 10 to the 120th power. No computer, no matter how fast, can check every single one before making a move. So if try everything is off the table, how does an AI avoid getting lost in an impossibly huge maze of possibilities? Quick quiz before we go further. Take a guess, then I'll tell you if you're right. Pause if you need a second. So, today we're breaking down the two-part trick AI uses to play games, how it looks ahead without checking everything, and how it gets better the more it plays. Picture a choose-your-own-adventure book with a million possible endings. You wouldn't read every single path to the end before picking your first choice. You'd glance a few pages ahead down each option, get a feel for where it's heading, and go with the one that looks most promising. That's basically what a game-playing AI does. It's called a search tree. At each possible move, it imagines a few steps into the future, and instead of exploring every single branch, it quickly discards the branches that are obviously bad and spends its time on the ones that actually look worth exploring. That one shortcut, called pruning, is what turns an impossible search into a manageable one. But looking ahead a few steps still leaves a huge number of positions to compare. So the AI uses something like a coach, glancing at a mid-game board and going, "Yeah, that position looks strong for white," without playing the rest of the game out. That's called an evaluation function, a shortcut score based on things like piece position, control of the board, and safety. Modern systems don't have this score handwritten by a programmer. They learn it from experience, which brings us to the second half of the trick. This is where AlphaGo, the AI that beat the world's best Go players, changed the game. Pun intended. Instead of learning from a giant library of human matches, it mostly learned by playing itself, millions of times over. Think of it like practicing chess against your own reflection for a decade straight. Every game, you try something, see whether it worked, and quietly adjust your instincts for next time. Multiply that by millions of games happening faster than any human could play them, and you get an AI that develops its own sense of good moves. Sometimes moves no human ever thought to try. All right, pause and answer time again. Quiz 2. Now here's the honest part. This approach works incredibly well in games. For one specific reason, games don't share with real life. Crystal clear rules and a clear win condition. That's exactly why an AI that can crush you at chess can't automatically help fold your laundry or merge onto a busy highway. Those problems don't come with a scoreboard telling the AI whether it's currently winning. Games are actually one of the easiest environments for AI, not the hardest, which is part of why AI mastered them first. You don't need to be building the next chess engine to use this idea today. Next time you're stuck on a decision with way too many options, a job offer, an apartment, a big purchase, try the AI approach. Don't try to evaluate every possibility. Narrow it down to your realistic top few. Imagine a few steps ahead for each one, and score how each path actually feels. That's a search tree, human style. And it's a lot less overwhelming than trying to consider everything at once. That's how AI plays games, not by knowing everything, but by looking a few smart steps ahead and learning from experience, one game at a time. And speaking of experience, next episode, we're looking at another skill AI has quietly gotten scary good at: writing code. How does an AI go from a plain English request to working software? That's next time. If this helped you see AI a little differently, hit subscribe. It's the best way to make sure future episodes reach you. See you next time.